Hello, geometry folks. Today we are going to be learning about other proportionality theorems, or other theorems that allow us to set up proportions between shapes and triangles and lines. So what you're going to need today are your notes and the label for notes, or that cutout that I gave you so that you don't have to draw all the examples, a pen or pencil, and also a calculator if you so desire. So it's up to you with the labels for the notes, or the little foldable, the purple foldable in this picture, if you want to leave it all as one sheet of paper and glue it into your notes, or if you want to cut them up so that you have some writing space to write around them. So I'm going to leave that up to you, whether you want to glue it in like this, give yourself some space on either side, or you can cut them out and space them accordingly. But this is just an idea of what our notes are going to look like by the end of this video. So let's start off the notes with the first theorem, the triangle proportionality theorem, and that states if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So what we mean is if we're saying if below our little image here we have these triangles being cut by two parallel lines, right? So we're saying if TU is parallel to QS, then RT, which is this segment right here, over TQ or 2TQ is equal to the side length RU, which is this highlighted side, to US. So what we're saying is that we can set up a proportion where this side length over this side length will be equal to this side length over this side length. We've been wanting to show that in all of our triangle similarity shortcuts, but now we finally have a theorem that states that. So let's look at an example. Okay, so somewhere around that first triangle proportionality theorem, draw this example, and we are trying to find x. So draw this into your notes as an example somewhere around that theorem. So we are assuming that MP and LQ are parallel because they show us that on the image right here due to these little red triangles. So we have to set up a proportion. We're going to say that NM, which is this side length 8, over x is equal to 24 over 12. And from here, it's just like normal. We solve by cross multiplying. So I'm going to take 24 times x first to get 24x, and I'm setting that equal to 8 times 12, which is just 96. Now I take both sides divided by 24, and I get x is equal to 4. So note that we are not saying 8 over 24 and x over 12. That's how we would set it up if we had triangles. We're just talking about the side lengths on the big triangle when they're being cut by these two lines. So you have to set it up as 8 over x and 24 over 12. You have to. So that is one little tricky thing with this theorem. Okay, so I failed you, and I forgot to give you this little theorem in your foldable. So somewhere around the triangle proportionality theorem, you're going to write all of this, the converse. So the reverse of the triangle proportionality theorem. Remember, converse means reverse. So get this into your notes somewhere beside the first theorem in your purple little foldable. So we're saying the exact opposite. So this statement is the reverse from the first theorem we went over. We're saying if a line divides two sides of a triangle proportionally, then it is parallel to the third side. So if we're saying TU divides two sides of the triangle RTU proportionally, then it is parallel to the third side. So if RT is over TQ is equal to RU over SU, then line TU is parallel to line QS. So we're saying if we find that this segment over this segment is equal to this segment length over this segment length, then we can say that this line and this line are parallel. Okay, so let's look at that second theorem, the parallel lines and proportions theorem from your purple foldable. Okay, so we're saying if three parallel lines intersect two transversals. In this example, or in this diagram, we're saying line R, S, and T. If those three parallel lines intersect the two transversals, L and M, then the three parallel lines divide the transversals proportionally. So what this means is it's easier to understand when we look at the image. So if we're talking about the three parallel lines cutting L and M, we're saying the portion between line R and S, or the line segment UW, over the line segment YW is equal to the ratio of Vx over Zx. So we're saying if we had three parallel lines, we can set up this proportion every single time. So let's take a look at an example of how that works. Okay, so somewhere around your second theorem in your little purple foldable in your notebooks, write this example. We are trying to find the length of AB. So this value right there. So draw these three lines, these three parallel lines, and the two transversals that are getting intersected. So we are saying from our theorem, we can set up the proportion 16 over x. This line segment's length over this line segment's length is going to be equal to the ratio of this over this. So it's equal to 15 over 18. And now from here, all we do is cross multiply and solve. So x times 15 gives me a 15x. And then 16 times 18 gives me 288. So I'm saying 15x is equal to 288. Now I need to divide both sides by 15. And I'm not going to get a clean number on this one. This is going to give me 19.2 for x. And that's okay. We are getting into the part of geometry where we're not always going to have exact answers. So don't let decimals freak you out, or square roots, or fractions, or any of those things. So our answer is 19.2. Okay, last but not least, we were talking about angle bisectors and their proportions. This theorem, so it's our last theorem in our little purple foldable. We're saying if a ray bisects an angle, So what that means is we are cutting the two angles here. So this angle is going to be equal to this little angle. That's what we mean by it's bisecting the big angle C. We're going to say that this angle is equal to this angle. It's cutting it exactly in half. So if a ray bisects a big angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So the opposite side from angle C would be AB, right? So we're saying this portion and this portion are going to be proportional to the sides that are adjacent to the angle. So it's probably easier to see if we just look at the ratio that they set up. They said AD, this side length, is over DB is going to be equal to AC over BC. So make sure we know that it's not AD over AC that we're doing like we did with our triangle similarity shortcuts. It's AD over DB. So the two segments that are being bisected across from the angle bisector, and then the other corresponding adjacent sides. So that's how we're going to set up proportions for these ones. Okay, so somewhere around your last theorem in your purple little foldable, make sure to get this example, and this is our last example for our video today. So we need to talk about which angle is getting bisected, and angle B is the one that's getting bisected. So our ray is BD, and we're saying that this angle is congruent to this angle, so that means that the big angle B is getting bisected. So the side opposite of B is AC. We know that DC is X, they gave us that, and we also know that the entire side length of AC is 40. So we can figure out that AD is 40 minus the DC portion, right? Minus this portion. So AD is just 40 minus X. So that's easy enough. So we're going to set up our proportions. And remember, we have our first ratio is going to be the pairs of sides that are opposite the angle getting cut in half. So I'm going to say x over 40 minus x, and that I'm setting equal to 32 over 24. Would it matter if we said 40 minus x over x? No, but then you'd have to do 24 over 32. So there are two ways that you can set this one up. And then from here, all we need to do is cross multiply and solve. 24 times x is going to just give me a 24x. And now I'm taking 40 minus x, that entire quantity, times 32. So first we have to distribute the 32 to the 40. 32 times 40 is 1,280 minus 32 times x gives me a 32x. Now I just solve like normal, solve for x, so get x by itself. So I'm going to get all the x's on one side, which requires me to add 32x to both sides. 24 plus 32 gives me 56x equal to 1,280. Now all I have left to do to get x alone is divide by 56. And again, I am not going to get a clean answer for this. I'm going to get a funky decimal. So 1,280 divided by 56 is going to give me 22.86. And if they asked me, what if they asked me to find the length of AD? All we would need to do then is take 40 minus the value that we found. So keep that in mind that we're going to be able to find other parts like that if they're set up in such a way. Okay, so I want to thank you for taking good notes, and I hope you have a great weekend. See you when we get back.